Hi, kids. In assignment number 4, one of the things that I wanted to do was take you to this website called Phet Simulations by the University of Colorado at Boulder. They've created a collection of a whole bunch of different interactives that explore all different types of concepts in science. So you'll probably come across this in your biology classes, your chemistry classes, and your physics classes as well. I'm using this one today called Molecules and Light. And it's one that allows us to delve more deeply into the concept of energy and matter and how those two things interact with one another. When you get to this page, you're going to have to go ahead and download it. You can do that in one of two ways. You can just click the play button here, or you can click the download button. That's my choice. And that will bring us to this screen here. And one thing we can do is we can click Show Light Spectrum, where we can use it to remind ourselves what the different forms of electromagnetic radiation are. We might remember that electromagnetic radiation is actually a spectrum ranging all the way from low forms of energy, radio waves, up to higher forms of radiation like gamma rays. When we did our cell phone lab, you guys might remember that we were really focusing on microwave radiation at that time. Microwave radiation, comparatively speaking, has wavelengths that are fairly broad, and therefore that means that they have low frequency and low energy compared to most other types of radiation. Today's focus is going to be mostly on infrared radiation, a slightly higher form of radiation than microwaves. Therefore, the wavelengths are a little bit smaller. All right. You can tell in this website that we can toggle through different types of gases, and all of these gases, by the way, exist in our Earth's atmosphere. And when we click them, we see that the molecule over here changes. I'd like to start with nitrogen, N2, which is 2 atoms of nitrogen that are bonded together in a triple bond. You can see 3 green lines in there showing us that it's a triple bond, a pretty strong bond. Anyway, the reason I'm using nitrogen is because nitrogen makes up most of our Earth's atmosphere. 78% of the gas in our Earth's atmosphere is nitrogen gas. Now, you can also see that we can toggle through different types of flashlights, for lack of a better word, and right now I have it clicked on visible light. So when I turn this on, it's going to start to shoot photons of visible light at this molecule of nitrogen gas. And I want to ask you, before I go ahead and do that, what do you think is going to happen? Knowing that our Earth's atmosphere is made mostly of nitrogen gas, would you think that sunlight will interact, or maybe a different way of saying that could be, do you think that the nitrogen will interfere with visible light at all? I'm going to give you just a couple of seconds to think about that. Okay, so think about when the sun rises every morning. Does the atmosphere get bright immediately, or is there some kind of interference going on? Well, it doesn't seem that way to me. And we can see here that photons of visible light cross over that molecule of nitrogen and are not interfered with at all. Same is true with microwave radiation. Same is true with infrared radiation. Same is true with ultraviolet radiation. So it seems like in terms of its interference with electromagnetic radiation, it seems that nitrogen gas is pretty non-interactive. But we're going to find that that's not always the case. Let's go back to visible light. And let me click on nitrogen dioxide. Watch what happens here. Sometimes it absorbs a photon of visible light and then redirects it. We call this scattering. And whenever a gas interacts with a form of radiation in this way, that means it's going to slow down the passage of that radiation. So you might guess that what I'm going to have you do in this assignment is I'm going to have you choose infrared radiation. And then I'm going to want you to go through and I'm going to want you to choose each of these gases. And I want you to see which ones interact with infrared radiation. If there is an interaction and you see that the molecule redirects or scatters the photons of radiation of infrared, then that would give you a good clue that it's a greenhouse gas. Thank you.